and kicked out a window, and the passengers went onto the track. They did not know whether the third rail was energized or not, but they were desperate to get out of the subway car. One person jumped into the river.
Más bien.
Now, she was okay, but that's the subway where I come from. So what do these things have in common? Well, they all are examples of organizations that have become stuck in the capability trap. So my goals for today are, first of all, what is this thing called the capability trap? And all of you are parts of organizations. You're part of the university. You're probably also working. So you're part of other organizations. You're part of your communities. So I'm going to want you to think about what capability traps you might be experiencing in your own personal and professional life and how it bears on sustainability. We're going to talk about how you escape the trap. It's not enough to point out a problem. You also have to have ideas about how to solve it. And I'll give some examples of that. And we'll talk, if we have questions, if you have questions about what the implications are. And as I said, you need to make your comments. You need to ask me questions as we go along. Is this okay? That's the plan. So as Santiago mentioned, I founded the Sustainability Initiative at the MIT Sloan School of Management in 2007. And I have a wonderful team backing me up. Part of what I do, I work on climate change. Who was with me in the morning for the climate change workshop? Fantastic. So you all experience the macro perspective at the global level. But a lot of my work is how do we make change happen at the local level? So I work with a lot of companies and a lot of organizations. And let me show you, see if I can get this to work. It doesn't. Okay, it's fine. So let me show you, this is what it looks like in one of the organizations that I've worked with. So when I go and visit these organizations, whether it's a company, fantastic, a company or whatever. Yep. No, it's a standard. Okay, got it. So I always want to go and look at the physical plant, what's really happening. So I go up to the roof. Yeah, you have magic fingers. Yeah, that's easy. All right, don't worry about it. So I go up to the roof on one of the buildings in this organization. You have this. So what do you see here? What do you see here? It's a real question. What do you see? Nothing is working, right? It's gone too far. You moved too far. Yeah. So now we try it again. We'll see what happens. Okay, so what you have here is an air handling system. The purpose of this is to bring fresh air into the building without having to lose all the energy that you've spent heating up in the winter and cooling down in the summer, the stale air that's in the building. But as you can see, it's rusted out, and in fact, it was inoperable, so it didn't do its job at all. You go down into the basement. There, it's working. Thank you, Santiago. You go down into the basement. This is one of the typical steam setups in the basement of one of the buildings. And, you know, what do you see here? How does this look to you? You don't have to be an engineer to tell me what's going on here. It's old. It's very old. In addition, you can see obvious signs of rust and corrosion. In addition, some of these pipes are wrapped with asbestos, which is toxic. And if you needed to turn those valves for some reason, it's highly likely they would not work. Okay? This is dangerous. So what else? Okay.
John, you have to point to the.
I have to point it here. Yeah. Okay. All right. So here we go. So this is another building in this organization. This is a window from the 1930s in an office. It's a single pane of glass. Now you have to remember this is in a cold climate, not here, not at 5 degrees latitude, but more like 43 degrees latitude. So it's cold in the winter, it's very hot in the summer. Single glazed window with a metal frame. And from the 1930s, and it's rusted in place, meaning you can't open it or close it. And you look at the bottom there, and there's a visible air gap. Oh, well, I'm sorry for the crazy American units here. 1/4 inch, right? That much. I was in this person's office in the winter one day. The wind blew and papers blew off her desk. So think of all the energy that's being wasted from this. Plus, it was ridiculously uncomfortable in her office. So what else is going on in this organization? Some of the exteriors of the building, there's obvious cracks and spalling, water damage. Here you see a crack. So in the winter, it might snow or rain, water gets inside, then the temperature falls well below freezing. The ice cracks it more. Pretty soon you've got maybe bricks falling on the sidewalk, maybe hitting somebody, maybe killing them. But also now the cold air goes inside the building and can freeze a pipe. This actually happened. The sprinkler head on the fire suppression system froze and burst, and now there's a flood. And that flood caused $100,000 US worth of damage. This is what their equipment looks like. Oh, one more thing. What about the electrical system? Take a look at this. So, first of all, this is really old. Secondly, it's kind of like the old electrical equipment you see in Frankenstein monster movies, right? It's that old. But the other thing is it's open. It's open in a hallway. And you probably can't read it. But the maintenance tech came by, saw this was a problem, and what he wrote here on the wall to try to protect people is danger alive, right? So this is a real situation, and what you see is old, decrepit, not maintained well, not working, wasting a lot of energy, and dangerous. And so would you like to know what organization this is? MIT. So this is a very important result. I've been on the faculty at MIT for over 40 years now, 42 years. I love the place, but this is a big problem. Why? First of all, MIT is a nonprofit organization. We're an educational institution. We don't have shareholders who pressure us for quarterly earnings going up all the time. We have a very, very large endowment, many tens of billions of US dollars. We have a long time horizon. Our mission is to make positive change happen to improve life on this planet for everyone using science and technology for centuries to come. And we are run by very smart people. So how can that kind of a situation happen in an organization like this? This is the puzzle, the mystery that we need to solve, and we'll do that together. So let me give you a few other examples. Does anybody here have experience in maintenance? In any, yeah.
Facility management.
Great, facility management. So what would be, so there's basically two categories of maintenance work. Something breaks, you have to fix it. That's called reactive maintenance or corrective maintenance. And then there's proactive maintenance, preventive, scheduled, predictive maintenance, and process improvement, right? And so what's best practice? How much of the maintenance work in a really good organization should be preventive versus corrective?
So I would say that, the most important thing is to, as you said before, try to have the preventive maintenance and also the corrective maintenance. I would say there are, one of the most important things in an organization.
Right, but so I'm from MIT, I'm looking for numbers. So any idea, what's the ratio of preventive to corrective that would be best practice?
So preventive versus corrective, I would say is higher.
Yeah.
So,
Great.
Maybe twice or 3 times.
Well, so I heard twice, 3 times, I heard 10 times. Best practice, whoops, so now it does too much. All right, we go back. I'm learning my lesson. I need to do this. Where's the mouse? There it is. I need to do this by hand. Okay. Best practice is that you should have about 6 times more preventive maintenance than corrective maintenance, okay? And what you see here is what was actually happening at MIT about a decade ago, 12 years ago or so, when one of my doctoral students and I began to study this problem. 45% urgent, another 40% corrective. So that's 85% corrective and only 15% preventative. So exactly the opposite of what it should be. It's not just MIT. This is a major hospital system in Boston that I worked with, and it's the same story here. 38% preventative, 62% corrective, and more than half of all the maintenance work orders were stat urgent or threatened the health and safety of patients and workers in the hospital. Stat means right now, urgent. Yeah. This is crazy. This is exactly the opposite of what it should be. And many other examples of this I could show you. So what I'm going to do now is how many of you have studied any system dynamics modeling in Santiago or any of the other faculty? Fantastic. So we're going to do a little system dynamics modeling together this afternoon. So how can an organization get stuck into this situation? Here's the basic framework. And of course, I'm simplifying, but you can keep this in your head and use it every day. Think about the performance of any organization you care about. For a company, how much can we produce? How much revenue can we bring in? How many new products can we launch? How many customers can we provide service for? In the university, how many students can we educate? Not just bring to class, but actually have you learn something. How much research can we get done, etc. Performance is anything you care about that your organization needs to do. And there's always a target that I'm calling desired performance. This is what you need to do. So the company needs to earn a certain amount of revenue and profit. It needs to launch new products at a certain rate. So for Apple, a new iPhone every year. In the university, we need to educate, graduate everybody in the class on time. We need to get research done. Those are the goals. There may be a gap. Actual performance may fall short of what's needed. And that's going to be called the performance shortfall. So I need to earn this much money in my company. I'm only earning this much. I've got a problem. Now, this kind of diagram is called a causal loop diagram. Those of you who have studied system dynamics, you know how this works. So very quickly, for those of you who may not, the arrow means a causal influence. So if desired performance were to, for example, rise, that would change the performance shortfall. Now, in what direction does it change it? So the plus sign here means if desired performance goes up, then all else equal, the shortfall goes up. It also means, the plus sign also means that if desired performance fell, the shortfall would get smaller. So the plus sign does not mean the shortfall is getting bigger. It means if the target is raised, the shortfall gets bigger. If the target falls, the shortfall gets smaller. They move in the same way. And then over here, if performance changes, it's also going to change the shortfall, but here it's a minus sign because given the target, if performance goes up, the shortfall gets smaller. So bigger performance, smaller shortfall. If performance falls, the shortfall gets bigger. So all okay? Okay. So you're going to see these polarities on all the causal arrows in the model. All right. So now, what determines performance? In the most general terms, it depends on two things. How hard is everybody working? How many people do you have? How many hours do they spend working? How productive are they? How good is the quality of their work? That's work effort. And then it also depends on your organization's capabilities. So what is a capability? A capability is, well, first of all, capabilities are multidimensional. It takes many capabilities for an organization to have good performance. You have to have skilled, committed people. You have to give them the right equipment to do their jobs. You have to have a supportive work environment where they trust each other and can help each other so that they can solve problems together, and many others. So capabilities are all of those It's that entire bundle of assets and skills and attitudes that are needed for high performance. So how about right here? Give me an example of a capability. Behind you, actually. I said I would call on people, so don't worry. Any ideas? So what do you need in your own personal work to be productive? I couldn't hear. Sorry.
Like organizing ideas and activities.
Right.
About what I need to do.
Great. And in order to do that well, maybe you have software tools to help you do that. Those software tools need to be working. They need to be compatible with the kinds of ideation you need to create. Fantastic example. Other kinds of capabilities? Anybody?
Cash flow.
Sorry?
Cash flow.
You need money, but the money isn't the capability. The money allows you to invest in improving your capability. It's like hiring good people and paying them a decent salary and training them and buying good computers. So the money isn't the capability, but it helps you build your capabilities.
Maybe you work in IT, in computers or.
Yep. Good quality IT systems and good quality IT people who can solve problems that the users might have, keep the network running, etc. These are all great examples. So here's the thing. Capabilities can be hard assets, like your computer equipment, like the quality of your buildings and your infrastructure, and they're soft or intangible. Skills, attitudes, trust, the trust of the people in an organization that they have with one another and between them and management trusting them. These are also capabilities. If any of you have ever worked in an organization where people don't trust each other, that's a big problem. You are going to have a low performance and a big shortfall. Is this all okay? Okay, now the question is, where do capabilities come from? It's easy to understand work effort. How many people do you have? How many hours do they work, etc. So let's take a look at this. So first, here we have this idea. If the shortfall is big and gets bigger, everybody has to work harder, right? So there's a plus sign on this arrow. That creates a balancing feedback loop. So how does this work? So imagine that desired performance goes up. What's the very first thing that happens? The shortfall gets bigger. The very first thing that people are going to do to try to close the gap is they're going to work harder. They're going to stay later. They're going to maybe try to get some more people on board. They're going to work more focused, less time for breaks, shorter lunches, etc. Work effort goes up. What happens to performance? Performance should go up. And so what happens to the shortfall? Shortfall goes down. Whew. Problem solved, right? That's what we call a balancing feedback loop. And this is, every one of you does this. You get behind in your schoolwork, you stay up all night to catch up, right? Okay, so much more interesting is what happens over here. So you see the diagram is a little different. That's because capabilities are assets. They are stocks. They're accumulations of past investments. So if you think about a hard asset capability, like the quality of the buildings that I just showed you at MIT, for people at MIT to be productive, they have to work in a building that's cool in the summer and warm in the winter and doesn't have a flood and is comfortable. And if the building deteriorates, that's not true. So that's an asset. You can improve the quality of the building by investing in maintenance and upgrades, but buildings also deteriorate. So this diagram here captures that idea. A capability is a stock. It's an asset. And it's built, so think of it like a bathtub. Think of that box of capabilities like a big, huge tank of water. Tank of water is filled up by the faucet or the flow in, and it's drained out. So The quality of your buildings is improved when you invest in maintenance and renewal, and it deteriorates as the buildings age and the equipment begins to fail, etc. So capabilities are stocks. They're filled up through this flow of investment. Think of that as a pipe that's filling up the tank, right? So this is a pipe with a valve, fills up this tank, and here's another pipe. That's the drain out of the tub, okay? Now, how do you build the investment and capabilities? Well, it takes money, but you have to allocate that money to investment, and that comes from improvement effort. Oh, our buildings aren't very good. We need to improve them. So we have to allocate maintenance activity, retrofit dollars, other costly time and effort to improving the building. There's a time delay between allocating that effort and seeing results. Okay? Does this all make sense? Okay. Now, here's the question. When we've got a performance shortfall, one possibility is the people that work for us are lazy and dumb and stupid and don't care and only care about their own personal weekends. And so we need to crack the whip and make them work harder. That's only one possibility. The other possibility is maybe our capabilities aren't what they need to be. And so you could have the most committed, hardworking people in the world, but they're working in an environment where all the equipment and all the assets are terrible and nobody trusts each other. So that is why performance would be bad. So you have to make a decision which one it is. And if you decide that your capabilities are not what they need to be, then what you do when the shortfall increases is you increase the investment in improvement. So what that would mean is instead of saying, Santiago, you don't work hard enough, don't come home until you finish that report. Instead you say, Santiago, our capabilities are terrible. Will you please become a member of the Six Sigma improvement team, earn a black belt in Six Sigma quality improvement, and help build our capabilities? Big difference. Now he still has to work hard in the second case, but he's working hard on improvement, not on just cranking out the widgets. So improvement effort goes up, and that means after delay, the investment in capabilities should go up, and that should pour more water into the tank. And that should raise our capabilities, right? So here's a question. Does it in fact raise our capabilities? Well, if it does, then performance will rise and the shortfall will fall, right? And things get better. That's also a balancing feedback loop. I'm going to call this one where I tell Santiago he can't go home until he's got that report on my desk. That's working harder. This one I call working smarter. You see the difference, right? Here, he has to work hard forever. Here, we improve the capabilities, and then the performance improves without us having to work hard forever. Now, which one is better? Working harder or working smarter? Everybody says working smarter. But here's the thing. In many organizations, including the ones I've just showed you, that's not what's happening, right? Instead of 6 times more preventive work for preventive maintenance than corrective work at MIT, at the hospital, and many other places, it's exactly the opposite. People are working really hard, but they're not improving. So how can that happen? So whenever you see a situation where people know what the right thing to do is, we should do preventive maintenance. We should invest in process improvement. We all know that's the right thing. We all know working smarter is better than working harder. But when you see situations where people are not doing what they know is the right thing, what you need to do is try to understand what are the pressures they're under that cause them to make a decision they know is the wrong one. It's not because they're evil, it's not because they're stupid, it's because they're stuck in a system that puts so much pressure on them that they can't do the right thing. Once I was teaching this in a class of executives, and I asked people, So, you know, maybe there's a better name for this feedback loop. I called it working smarter. What would you call it? And one gentleman raised his hand and he said, yeah, let me tell you, in my company, we call that the "it ain't gonna happen." Because, you know, we all know it's what we ought to do and it's not happening. So now, here's the example. This creates what we call the capability trap. So here's how it works. Performance shortfall goes up. We allocate more effort to improvement. After delay, the investment in capabilities goes up. Does that mean that the capabilities improve? System dynamics people, this is something you should know. So we've now increased the investment in the capabilities, right? We're doing more preventive maintenance. We're buying better computers. We're doing all those things. We're putting our workforce into training. We're taking them for beer to build cohesion in the team. Does that mean capabilities are going up? And the answer is not necessarily, because you need to think about it like a bathtub. You need to think about it like a bathtub. So here's how a bathtub works. Here's your stock of capabilities. It's like the water in the tub. Here's the faucet that's filling it up. That's the investment in capabilities. And capability erosion, things get old, things wear out, people leave the organization and they take their skills away with them and they take their relationships away. Trust is eroded when people don't do what they said they were going to do and they don't look out for their fellow workers. That's the drain. So how does a bathtub work? Well, you could turn the faucet up, but that does not mean the amount of water in the tub is going to go up, because the amount of water in the tub will only go up under what condition? Let's try right there, gentlemen with the phone. So what's going to happen? In order for the amount of water in the tub to go up, what has to be true?
Can you repeat me in more slower,
Sure.
please? My English.
That's okay, and maybe Santiago, you could translate. So, go ahead.
¿Qué se necesita para que el nivel de capacidades crezca?
Pues, great. So you're familiar with tanks of water, yes?
Yeah. Sorry, I am nervous. I guess in the first place, what did you say, Tina?
Yeah, you can.
Go ahead and do it instead.
Okay. More of all, maybe the capacity of operation.
Eso te sirve en español.
Pues,
En español.
Sí.
yo diría primero una tienda muy grande, y el segundo,
Okay.
sorry,
It's okay.
nervous.
Thank you for trying.
Yes, he's saying that a larger part.
You need an RV, yeah, okay. So here's the thing, right? In order for the amount of water to go up, you have to be adding water to the tub faster than you're draining it out. You could, suppose 10 liters per minute are going in, but 20 liters per minute are going out. What happens to the amount of water in the tub? Right? So in order for the amount of water in the tub to be rising, in order for your capabilities to grow, you have to be adding new capabilities, investing in capabilities faster than your capabilities are eroding. And people do not understand this idea. They think if we spend more on training, if we buy better computers, things are going to get better. Well, you could do that and still have your computers and your equipment and everything deteriorating faster. Things are still going to get worse. So let me give you an example from real life. I showed you the subway in Boston on fire. So we call it the MBTA, the Massachusetts Bay Transit Authority, and we just call it the T. So in 2009, a study was done, how safe is the T? And you can read the conclusion here. They found 51 unaddressed safety issues that, quoting here, pose danger to the life or limb of passengers and employees. Meaning if you ride the subway, you could die. And some people have. They estimated it would cost $543 million to fix that, but only 9% of that was actually allocated. So what do you think is going to happen? Equipment keeps deteriorating, more and more problems, more and more accidents and injuries, and that's of course exactly what has happened. So let me show you the data. So, well, here's a picture of a derailment on the subway line, and here is an escalator in one of the stations. It failed suddenly and everybody fell down at high speed, and many of them were injured and had to go to the hospital. And that's just a small example. Literally, people have been killed riding our subway. So this has been going on for decades. So back in 2007, the managing director of the T was interviewed in our newspaper, the Boston Globe, and maintenance was chewing up 95% of the capital budget. Okay, so that means only 5% of the capital budget could be used to improve service or add a new line or anything like that. And that had been growing steadily. So Mr. Grabowskis, the managing director of the T at that side, he said, look, we would have to spend $550 million a year for 20 years to get to what's called a state of good repair. So you know what a state of good repair is. It means it doesn't mean everything's perfect. It means things are kind of running the way they ought to be running. Yeah. Yeah. So then he went on and he said, we're only spending 450 to 470 million. We're not spending anywhere near what we need to be. And he says, one of the depressing aspects of my job is realizing that even spending $500 million a year, we're barely keeping pace to keep the level of maintenance that we have today. I have to keep spending just to maintain the level of disrepair that we have today. So this is about the balance between the flow into the tub of capabilities versus the flow out. So I got the data. So here, since 2001, is the capital budget for our subway system. And it fluctuates a little, but by 2019, just before the pandemic, it had approximately doubled, almost $1 billion a year, $1 billion a year. So over those 18 years, the capital budget had doubled. Everybody thought that means the subway has to be getting better, including the governor, the ex-governor. Charlie Baker, I've met him, briefed him on the climate work that we did this morning. Smart guy, capable guy. From his point of view, we've nearly doubled the capital budget and things are still getting worse. In the minds of a lot of people, what that meant was our workers don't care, they're lazy, and that's the problem. But even doubling the amount we're spending to improve, here's what happened to the backlog of deferred maintenance. So the backlog of deferred maintenance is the amount in the bathtub representing all the maintenance work we should have done but have not done yet. And it started out, it was $3 billion in 2009, and it has steadily grown. 2021 was the last data I could get, $13.7 billion. That is a much faster growth of deferred maintenance than the rate of inflation. Much, much faster. What that tells you is spending double, it's still less than the rate at which the equipment is deteriorating. And so the backlog of deferred maintenance just explodes. This is exactly how we get into the capability trap. So the consequence, you already saw this, but this is a memorial to a gentleman named Lalin Robinson. He was riding the subway about 1.5 years ago, and he got stuck in a door,
That should never happen. The doors are designed to open up again if somebody's stuck, but that safety system failed because of poor maintenance. Then the train, if there is somebody stuck in the door, the train should not be able to start. That system didn't work. And finally, the operator should not allow the train to start if anybody is stuck. All three of those layers of safety failed. The train started, he couldn't get out, and he was dragged to his death. That's what happens. And it's so bad that the federal government has come this close to taking over the T and putting it under federal control because it's just so terrible. This should scare you. Imagine, so I've now ridden your metro, it's fantastic. But imagine if your metro operated like this, who would be still riding it?
In Colombia, that's the situation happened too.
In
Colombia.
Bogota or here?
Bogota.
Yeah, okay, so.
It's principal in San
Yeah, so this is the most recent plan that our subway system has to solve this problem. And they are saying there's 450, it used to be 51, now they're saying 450 safety-related projects, and they're allocating $7.5 billion to solve this problem. But what do we know? We know that $7.5 billion for 5 years is not anywhere close to what is needed to work off that backlog of deferred maintenance. So this is the capability trap. You have a shortfall, you try to improve, investment goes up, but capabilities will not rise unless and until the investment has risen enough to be bigger than the erosion. You could also reduce the erosion. I'm not showing that here. If that happens, then capabilities will grow, performance improves, and the shortfall goes away. But wait, there's another problem. Santiago, I'm telling you to work harder on that report. How much time do you have to work on process improvement? None. So the harder people work, because there's a big shortfall, the less time there is for process improvement and preventive maintenance. So we have a new link. Harder work, lower improvement effort. So what does that do? Shortfall goes up. Everybody has to work harder because that's the fastest way to solve the problem. But improvement effort goes down. After a while, the investment in capabilities goes down. And when the investment in capabilities falls below the erosion rate, now the capabilities are falling. And that means performance will fall. And that means the shortfall is bigger. And now Santiago and everybody else has to work even harder. And there's even less time for improvement and less time for preventive maintenance. And around we go in a vicious cycle. This is, those of you who are doing system dynamics, this is a reinforcing feedback loop. And here it's going to operate as a vicious cycle that just gets worse and worse and worse. So that's how the capability trap works. Yeah, question. Go ahead.
Knowing that if we continue working this way, it would get worse every single time, would it be better to keep the system like in a bad situation for a while when we focus all of our efforts investing?
Yeah. So you're asking exactly the right question. If I can rephrase, the question is, if this is happening, what's the best way to get out of the trap and stop it? Should we slow down work for a company? Do we stop introducing new products? Imagine Apple. I've worked with Apple. They're not in this situation. But imagine that Apple said, okay, next year, no new iPhone because we have to improve our processes. That's going to be really hard to do, right? But this is exactly the right question. So let's do a little mental simulation. So imagine you've got a factory. Let's imagine it's an oil refinery or a chemical plant or any kind of manufacturing facility like that. And here we have time. The top graph shows how much we're spending on maintenance, reactive, this much reactive, much more proactive. So this is the way it ought to be. And then down here, if you're doing this, The uptime of the plant is very high, performance is high, it's safe, it's reliable. You're doing great. Okay, now,
There's a recession, or the price of oil shoots through the roof, for example, as it did after Putin invaded Ukraine. So now the company is losing money. The memo comes out from the CEO, everybody has to take a 10% budget cut. Every plant, and I'm the plant manager, so I have to get 10% lower costs right now. So I send a memo to the production supervisor and HR and maintenance, and I say, okay, you need to take 10% out of your spending right now. Okay, how are you going to do that? And when stuff breaks, you still have to fix it. So where are you going to get your 10% budget cut? Out of the proactive, out of the preventive, out of the process improvement. You're going to cut that. What is the very first thing that happens when he does that? The very first thing. Costs go down. What's the very first thing that happens to uptime? It doesn't go down. It goes up. Why? Because operable equipment that would have been taken offline for maintenance now stays online because we're cutting the preventive maintenance budget. So the very first thing that happens is costs go down. Great, good job. And uptime goes up. You're a genius. You cut costs and you improve performance? Fantastic. Why didn't you do this before? Okay, but now what's the next thing that's going to happen? You're not doing preventive maintenance. You're not investing in process improvement. You're not building your capabilities. So what's the next thing that's going to happen? Correct. Right. Now, things are going to start deteriorating, right? Defects are going to accumulate. Breakdowns are going to occur. And this is where you're going. You're going to see performance goes down. That means the amount of reactive maintenance you have to do goes up. And as it does, now he has to take more and more and more out of the preventive work in order to keep costs from exploding. So this band right here gets smaller and smaller and smaller. And in the long run, where do we end up? We end up with a plant that's performing very, very poorly and is very, very expensive. We're paying more and we get less. So let me give you a different real life example. This is the Texas City oil refinery. Texas City is near Houston. It suffered a catastrophic explosion in 2005. And as you can see here, 15 workers were killed and 180 were seriously injured. That's the fireball. You can see some of the damage and you can see some of the memorials for the dead workers. So how did this happen? Right? Because people tell me, look, no company, no management would be so foolish as to allow themselves to get stuck in the capability trap. Well, so let me show you what happened. Okay. So in 1998, the training budget at the Texas City refinery was $2.8 million a year, and they had 28 full-time trainers to make sure everybody followed safe practices and do the right improvement. In 1999, BP, British Petroleum, bought the refinery from Amoco. And then the first thing they did was they said, you have to cut costs by 25%. 25%. So where's that going to come from? Well, it's going to come out of safety and preventive maintenance. Meanwhile, a safety audit said, we're likely to kill somebody, have a fatal accident in the next 3 to 4 years. Capital spending fell by 84% over that decade. 84% cut in the investment in upgrading and improving the equipment. What happened next? By 2004, the training budget is now half of what it was, and there's only 8 trainers to make sure everybody is doing the right thing on safety. Another audit revealed 23 deaths over the previous 30 years. This facility was a serial killer. So what happened next? The CEO of BP comes and visits. He congratulates them on their personal safety record. Personal safety means be careful. Process safety means we've designed a system that's intrinsically safe, and that ordinary humans who are tired, who may be inexperienced, who may be distracted, can't get injured. Difference, personal versus process safety. So there's great work on personal safety. People aren't falling down the stairs and so forth, but we still need to cut maintenance another 25%. Another safety audit shows very poor conditions and predicts that there's going to be a fatality in the next 12 to 18 months. This is in early 2005, and in March, the explosion occurred and 15 people were killed. So this is how it happens. Relentless pressure to cut costs. The costs come out of the investment in capabilities. Capabilities deteriorate. It becomes unsafe. There's more emergency corrective work, even less time for improvement until something terrible happens. Okay? Now, that's bad enough. But now, go back to our plan. Now we're stuck in the trap. So a huge amount is being spent on reactive maintenance and almost nothing on proactive because we don't have any time, we don't have any budget, we've cut our trainers, etc. And performance is terrible. And you come to me, you're the maintenance manager in this plant, I'm the plant manager. You come to me and you say, boss, we're in a terrible situation, and I know what we need to do. We need to spend more money. You need to increase my budget so that I can begin to do more preventive work. At the same time, we still have to keep correcting the problems. And you tell me that if I give you that money, I'm going to look bad with corporate, but if you tell me if I give you that money, things are going to get better. And you're very persuasive, so I say yes. So what is the very first thing that's going to happen to costs? Costs are going to go up. He predicted that. What's the very first thing that's going to happen to uptime? It's going to go down because I now have to take the small amount of equipment that's still operating and I have to take some of it offline to do the improvement and the maintenance. So the very first things that are going to happen, costs go up, performance goes down. I call you into my office and I say, you promised things are going to get better. We're spending more, things are worse, you're fired. Or you're worried that you're fired, so what's going to happen? What's going to happen to the improvement program? We're going to cancel it, right? Clearly things are going the wrong way, so we're going to cancel the program. And that's the trap. We try to do the right thing. Things got worse. And so we say it's not working, we kill the program. But now you are the new maintenance manager at Casitas. And you come back, and I was probably fired too. So now you're the plant manager. You come back and you tell your new boss, we need to spend more to get out of this trap. And you agree, and you don't give up. So what's going to happen? The very first thing is costs go up. Uptime goes down, performance gets worse, but you don't give up. So now what's going to start to happen?
Costs are still going down because you're spending less on reactive maintenance.
Right.
And uptime starts slowly going up.
Exactly. So things are slowly going to get better because you're now investing in your capabilities faster than they're eroding. And as that happens, reactive corrective maintenance goes down. And so here's what's going to happen. This does require one more thing, right? So things get worse in the short run, then they start to get better. And in the long run, lots of spending on preventive work and process improvement, very little on corrective, high performance. But notice that things get worse before they get better. We call this WBB, worse before better. There's a fundamental trade-off here. And you have to be willing to sustain that period where it gets worse before it gets better. Otherwise, you're going to abandon the program and stay stuck in the trap. Now, there's a couple other things about this that are important. The first thing is, how do we get this to happen? You have to make an affirmative decision
to reinvest the initial savings in further improvement. If you say, okay, we've done the first set of training for our people, and now everybody's trained up on good maintenance procedures, and everybody knows how to do it better, and so our maintenance staff, they're 15% more productive this year than they were last year, so we can downsize by 15%. We had 100 of them, now we only need 85. Then you chunk this off, it's never going to happen. What you have to do is make the decision to use the improved productivity to reinvest in still more improvement. And that requires what I'm calling an affirmative decision, meaning it's not going to happen automatically. What would happen automatically is productivity went up, we have people who don't have enough to do, let's downsize and save the money. It will make corporate headquarters happy. That you have to reverse that. You have to make a positive affirmative decision that we won't do that. We're going to reinvest those resources. What that does is it takes this reinforcing feedback loop, and instead of a vicious cycle, well, watch what happens. So we've increased the improvement effort. With the delay, the investment goes up. When that investment in capabilities rises above the erosion rate, capabilities will rise, performance goes up, the shortfall goes down. People don't have to work as hard, and now we reallocate their effort to further improvement, and around we go in a reinforcing feedback loop that's now working as a virtuous cycle, not a vicious cycle. And that's why this loop is called reinvestment or ruin, because it can go both ways. The vicious cycle direction happens kind of automatically when times get tough, people cut the investment. The virtuous cycle direction does not happen automatically. You have to make it happen. Okay, questions or? Yeah.
I have some comments. So, you know what? So, you said something that is really important. This is something that is really important in facility management and in the corporate sector, because, you know, when you try to say this information to CEOs, so most of the time they don't understand. Most of the time they're just thinking about money, they're just thinking about revenue, and
Short term.
they don't understand the facility management, process, normal process, and this is the typical, typical fight between facility managers and CEOs.
Right. So part of what we do is we create what we call management flight simulators, like the climate model some of you worked with this morning. In this case, it's a physical board game that was created by colleagues of mine who worked at DuPont at the time. I didn't create it. And people play, they play a simulated plant. And I'm not going to show you that. It's a whole different presentation. But what happens is they gain personal experience of what it would be like to be able to escape this trap and what they have to do. And it really works. There's lots of evidence about this. I'll make sure you get papers that describe this that you can make available to everybody. So let me now give you some real world examples. Okay, we'll take a couple more questions. So why don't you go ahead first?
So far, we have talked about improving our capabilities, knowing that we have to invest in our capabilities and they have to surpass our capability erosion.
Right.
But isn't there a way for us to also, while investing in our capabilities, to reduce the rate that we
Absolutely. So the question is, how can we not also escape the trap by reducing the erosion of capabilities? Absolutely. I'm just not showing it there, but imagine another arrow that goes from here to here with a negative polarity. That's going to create another reinforcing feedback loop. So fill the tank faster, reduce the drain faster. What would that look like? That would be investing, buying better equipment that lasts longer. It would be spending more time building trust and respect among your employees so they don't quit so much, etc. And this is very, very important, and we do that all the time. So, fantastic comment. One more, and then one more, and then we're going to move on.
When you mentioned about the corporate and being angry or happy, that's something that makes me think about the salary performance, because many companies actually have a a gap of what they can do with Samanara and on their, expected investor return. Can you kickstart this capability trap or the escape of the capability trap by reducing desired performance as well?
Yeah, so in the United States and many other countries, it's gone in the other direction. More and more executive compensation, CEO compensation is based on short-run stock price. My options vest in a year, et cetera. I get a big, huge bonus. That tilts the playing field towards the short term, and what you really want is longer term performance driving executive compensation and the ability to claw back what they've been paid in the past if things go wrong. I'll tell you a very fast story about this. During the mainframe computer era, IBM was the dominant company by far. I mean, they had almost all the market share. They also had the most expensive computers. That doesn't make sense. People should go with the cheaper computers. How come they had the biggest market share while still charging the highest prices? And the answer is they had the best sales and service organization in the world. If you used IBM equipment to do payroll or HR or anything for your company, and there was ever a problem, they would solve it like this, and they would do anything to solve it for you as fast as possible. Now, why? Turns out, back then, if you were an IBM salesperson, your compensation was based on the net present value of all the future revenue forever from all your customers. So if one of your customers becomes unhappy and says, we're switching from IBM to Amdahl or digital equipment, you would have a huge amount of your compensation clawed back. And that created an incentive for IBM salespeople to do anything to keep their customers happy. And that's what's needed here. And it has been done, it can be done, and there's some interest in doing it through legislation at the federal level in the US, although right now that's not going to happen in our Congress. Okay.
Yeah, you're supposed to, your decisions are supposed to be based on your capabilities plus your performance at the end, because it's what you, but it seems that you don't have a measurement of the level of your plan.
It's very, very hard to measure capabilities.
And that's why I have a question, because in accountancy that is always a challenge, and for financial people to put some numbers in there in order to get some valuation at the end of those kind of.
This is a
Is there some experience?
This is a fantastic comment. You know, the quality of our equipment, we can probably measure that, right? So we know the backlog of deferred maintenance at the MBTA, the subway in Boston, is $14 billion. But the capabilities of our people, the skills and the trust and the respect, these are hard to measure. They are very real, and they matter, but they're hard to measure. So what organizations tend to do, instead of directly measuring the capabilities of their people, is they measure how many training days did we schedule. That's not the same thing. One of the capabilities that an organization needs to grow is the capability to measure its capabilities. One way to do that is the old-fashioned way, what we call management by walking around and talking to people and getting to know them and understanding if they're happy or unhappy, and are they burned out, and are they having trouble because there's no childcare and so they're frazzled at work, or and what can we do about that? So there are ways to do that, but a lot of these capabilities are off the balance sheet. They're just not there, even though they're absolutely decisive in affecting performance. So now let me give you some examples. I gave you some examples of organizations stuck in the trap. That's not good enough. We need to see examples of organizations that have escaped the trap. So my first example is the Broad Institute. The Broad Institute is arguably the world's leading genetic sequencing research organization. It's part of MIT. It's located right across the street from my office. And it was endowed by Eli Broad and his wife. And you can see what they do here. They have a huge gene sequencing factory.
around the corner from their headquarters building. And what they're doing is leading edge biomedical research. This is where CRISPR was invented, also in Berkeley. But these are the people that are going to cure cancer, cure diseases, make a difference for humanity going forward. So this is Sheila Dodge. Sheila is an alum of our executive MBA program. I had her in my class. My colleagues, Nelson Repenning, worked with her very closely. When she went through the system dynamics class in this program, she learned about the capability trap. Her job is to run the gene sequencing factory. So what does it look like? It's in an old building around the corner from the headquarters, not nearly as nice and fancy as the headquarters. It used to be a beer distributorship, and the Broad Institute took it over. And if you go in there, as I've done, down in the basement, there's row after row after row of gene sequencing machines. Each one of those machines costs more than $1 million. And what this factory does is, if you're a researcher, you need to sequence the genome for a bacteria or a virus or some humans that have genetic diseases. You give a sample to Sheila's organization, they sequence it, give you the results. Now you can do your research and maybe win a Nobel Prize. Okay? So here's what was going on. They were deeply stuck in the capability trap. It's a fantastic organization. They were the leaders in the Human Genome Project that many years ago sequenced the human genome for the first time. But when Sheila was starting with our program, they were in bad shape. It took 120 days or more from when you submitted your sample until you got it back. That's a good chunk of a year. That means your competitors working on the same issue are going to scoop you and you're going to lose out for that Nobel Prize. This is a big problem. And as a result, they were losing demand. People were taking their work elsewhere. And the average utilization of those $1 million machines was less than 50%. You got a machine that costs $1 million and it's only in use less than half the time, and it still takes 120 days to turn around the samples. This is the symptom of the capability trap. So how did they get out of it? Well, she took system dynamics. She learned about the capability trap. She then learned some specific process improvement tools that were developed by my colleague Nelson Repenning and his colleague Don Kiefer. And they call it dynamic work design. I don't have time to go into the details, but you can see what happened here. So they identified their key capabilities. Where are the bottlenecks? If you went to the gene factory before they did any of this, and you went downstairs, it looked like people were incredibly busy and productive because everybody's running around like crazy, carrying trays of samples and getting output from the machines. That's not an indication things were great. It's an indication that they were scurrying around and everything was an exception and everything had to be done on an emergency basis and things were out of control. So long story, but they applied these tools and you can see what happened. The number of steps in the process was cut dramatically, so greatly simplifying it. The cycle time fell by a factor of 10. 120 days goes to 12 days. Utilization goes from less than 50% to more than 85%. That lowers your costs. And so now they're able to process more than 1 million samples a year. And you can see the variability also got much smaller. This is a huge success story. How did they do it? They did it by reinvesting the initial improvement in further improvement. There were also changes in the process. This wasn't just a technical thing. They have every day a meeting with a visual management board. The visual management board, I don't have a picture to show you, but there's basically Post-it notes showing what's happening to every process and every improvement program. And it's a way to make visible the capabilities and who's working on them and are there any conflicts and where are the bottlenecks. They have this meeting every morning and everybody sits around in a circle and they can see the board. It's not based on opinions, it's based on the situation. And every time they solve a problem, they take the Post-it note off the board and put it on a big spike. The stack of Post-its last time I was there was like this. So that's really good for their morale too. So what are the consequences? By building their capabilities,
then when COVID hit, they could pivot like this
from doing the research to doing the PCR testing on COVID samples. And this made a huge difference. There's no question at all that their ability to rapidly sequence tests and give people PCR results, highly accurate, within 24 hours saved a lot of lives. MIT and many other organizations use this very often. So in order for me to be able to go to the campus, I had to have a negative PCR test. Very often I would bring my sample in the morning and I would have the results before 5 o'clock that afternoon. I mean, it was that fast and it was really, really cheap. So through July of last year, so arguably when the pandemic was on the way out, they processed 36.5 million tests, 43,000 tests a day. 43,000 tests a day. And average turnaround time, less than a day, very, very, very cheap. This unquestionably saved lives and improved the productivity of all the organizations, including MIT and Harvard and others who used it. And now if you go down there, it's quiet, it's peaceful. It doesn't look like much is happening because everything is running smoothly and productively. We don't have breakdowns. We don't have sudden problems. It's just a remarkable turnaround. So that's an example of escaping the trap. Yeah. Yeah. Well, so So now what I want to do, I've got other examples, but let me talk about MIT. So we started with MIT about 10 years ago. One of my doctoral students, John Linus, for part of his dissertation, we worked on this problem, the MIT capability trap around maintenance. And we published a paper here. I'll make it available. You can send it to everybody. It's called How to Save a Leaky Ship. So what's going on? Well, remember, this is MIT. And here's a more detailed map in 2012 showing the condition of our buildings. So the red buildings, very poor condition. The orange ones, poor condition. The yellow ones, moderately poor condition. And the gray ones, either they're in good condition or we have no idea. The campus was in bad shape. Well, this was 10 years ago, right? So what we did was we did a system dynamics study to try to understand how MIT could get stuck in the capability trap. So $2.5 billion of deferred maintenance around 2010. And the maintenance staff was doing, I showed you the data, right? Everything was urgent, reactive work. What that looked like was, pipes are leaking in this building. There's been a release of hazardous material over in this building. Professors call up and say, my classroom is too hot, my classroom is too cold. These are called hot and cold calls, and they were by far the majority of the maintenance work orders. Everything was urgent, I got a class right now, come and fix the problem. So we were deeply stuck in the capability trap. We're spending more money on maintenance than we ought to be. We're using more energy and producing more greenhouse gas emissions than our peer schools. And some of the buildings were in such bad shape that it was hard to recruit and retain faculty and research and support staff. Students would come and visit the school and go, ew. And then they'd go to Stanford. And that's not good for us. We're better than Stanford. My daughter went to Stanford. I love the place. But come on, come on. We don't want to lose a student to Stanford or Harvard because they don't like what it looks like because everything is decrepit. So this is a big problem. And so we did a multi-dimensional system dynamics study, which meant my student, John, did field work. So he went and interviewed the maintenance technicians, the supervisors, all the way up to the chairman of the MIT Corporation. That's the chairman of our board of trustees. So everybody from top to bottom in the organization get interviews using ethnographic methods, and we got the quantitative data.
So here's a quote from a maintenance employee, a facilities employee. It says, look, it's a fire drill. We have to respond to whoever is screaming right now. So our priorities change hourly or half hourly. It's basically a constant fire drill. So once you get the equipment to the point where the customer stops complaining, then you leave it alone. In other words, we fix the problem, we don't fix the underlying capability. And that's the way everybody in the maintenance organization felt about it. Also, another quote here, we have a lot of deferred maintenance. We're not doing, we need to be doing 10 roofs a year, but we don't have the money to do it, so we're only doing 2. That means capability, so roofs are going to leak, and then equipment and research will be destroyed from the resulting leaks and flooding. The equipment is supposed to be looked at every week. Well, we can't do that. We can't even do it maybe every month or 2 months, so maybe only twice a year because we just don't have the resources. So we did what's called a model-based case study. So we built a detailed, quantitative, formal system dynamics model of the entire MIT campus with maintenance activity, work orders, productivity and skill of our employees in the maintenance. We modeled the state of the equipment. We modeled the energy use by building down to the individual item level, and we modeled the financials. So this is one piece of a large database that the Institute had put together with a consultant that shows the condition of every individual system and piece of equipment in every building on the campus, thousands and thousands of items. And what it tells you is, in this building, we have certain kinds of plumbing, gas supply, heat generating system, boilers, etc. How much did it cost when it was built? When was it built? Was it new or replacement? What is the projected lifetime? What building is it in, which I've covered up, et cetera, et cetera. So a very detailed database built into the model. And here's the result of the simulation. So in the paper, you can read about how did we build the model and how did we test it and how did we make sure it was appropriate and so forth. I won't spend any more time on that. But here's the base case. So it goes from 2005 to 2030. And in the base case, which says we just keep doing what we've been doing, MIT would collapse. Why? Because the backlog of deferred maintenance would just steadily grow, because the total amount of maintenance, proactive maintenance, as I showed you, was very, very tiny, and it would get even smaller. Here's best practice. Here's what we were doing. And so the backlog of deferred maintenance would get worse and worse and worse. The stock of defects would keep going up, and energy use would go up because those air handlers would fail, the windows would crack, etc. So you're wasting more and more energy. This can't happen because it would mean MIT would collapse. So then we looked at policies that we could implement. So one of the things that people proposed back then was, okay, we need to get on top of this backlog of deferred maintenance, but we don't have a lot of money. Now, MIT has a lot of money, but doesn't matter how much money your university has, everybody wants more for what they do. Financial aid wants more to help students of limited means. Researchers want more to do more and better research. We want tuition to go down, et cetera, et cetera. So there's enormous competition for the dollars. So what people used to say is, why don't we just spend extra on maintenance for just a few years? And that should, and they would call it the surge, right? So we'll have a surge of extra maintenance. We'll get on top of the situation and everything will be better. So we simulated that. We also simulated a policy of heavy investment in what we call campus renewal, which means we're going to take some of those buildings that were in red on the map and we're going to do a complete renewal, refresh everything, retrofit everything. So let's look at what happens. So the maintenance surge is $5 million per year more for maintenance for 5 years. That's a 33% increase in the maintenance budget. That's a big jump in the maintenance budget for 5 years. The renewal surge is $150 million per year, also for 5 years. That's a 650% improvement in
campus renewal, retrofitting and renewing buildings. That looks like a lot, yeah? You can imagine people pushing back and saying, that's a lot of money, we could use that in a better way to keep tuition low or provide more student financial assistance. So what happens? Well, in the maintenance surge, almost no impact at all. The green is very close to the base case here. Total defects go down just a little bit. Look what happens to the green here. This is the maintenance surge. It allows us to do more preventive maintenance, but we can only get up to around 25%. Best practice is up here. And then what happens when it ends, we drop back to where we were. In other words, we're not getting over the tipping point where we're building our capabilities. So when the surge ends, we fall back into the trap. And it's the same story with the bigger amount of money for renewing buildings. So you spend this $150 million a year for 5 years, and the backlog of deferred maintenance does go down, and the defects go down for a while. Energy use goes down, but then it starts to grow again, and defects start to grow again. Why? Because things got a little better, so that allows us to do a little more preventive maintenance, but still not enough to get over the tipping point, and so we're dragged back down. So this doesn't work. This is like the MBTA, going from $450 million a year to almost $1 billion a year in capital budget, and things are still getting worse for exactly the same reason. You're draining your tub of capabilities faster than you're filling it up. So then here's another one. So what if we spent that $150 million a year on campus renewal every year, all the way through to the year 2030, starting in 2010? Now what happens is the backlog of deferred maintenance goes down quite a lot. Fantastic. Total defects go down quite a lot. Fantastic. We free up enough resources that we can now do about 35% preventive maintenance instead of nothing. And our energy use flattens out because we've renewed more of the buildings. So this is much, much better, but it's still not what we need to do. So what's the financial return to this? We keep track of the financial return for all these policies. The one I'm just showing you now has a negative net present value of almost $3 million. So it's a financial loser, but it does save 0.6 billion BTUs of energy. Now, a BTU doesn't matter. Crazy English units, imperial units. But it saves a fair amount of energy, but it doesn't really do what needs to be done. So what about the renewal policy? And while we're renewing a building, let's dramatically improve its energy efficiency. While you've opened up the walls and you're going to replace the plumbing and the heating system, do the extra work to improve energy efficiency. Okay, well now what you see is the backlog is about the same, but energy use goes down a lot more. Great. The net present value of this is now $58 million. So this is profitable. This is profitable. $58 million net present value with a payback time of only 12 years, and you save a lot more energy. This is really good. But we can do better. In this scenario, we're not reinvesting the savings from spending less on energy or maintenance. We're not reinvesting them in further improvement. We're using the savings, the energy budget, the energy costs go down, and we're using it to keep tuition low or give more financial aid or improve research or pay professors more. Well, okay, that would be a good idea. All right. So we looked at one more policy, and this policy says, no, don't do that. Take all the savings from better maintenance, fewer breakdowns, and especially from lower spending on energy, and reinvest it in further improvement. Now what happens is, take a look, things are better, energy use goes way, way down, and
Now we get up into the zone where we're doing the right thing. We're able to do preventive maintenance
at the right level, the best practice level. And the net present value of this, almost $100 million. This is a hugely profitable activity, hugely profitable
policy. And we save much more energy. Now, the largest gift that MIT had ever gotten
from a donor when we did this work was $100 million. That's a lot of money. Since then, we've gotten bigger gifts. This is the same amount. You can imagine how hard it is and how infrequent it is to have somebody love MIT so much that they're willing to give us $100 million. We could do this and generate the same thing. So, what about the cash flow? Right? So things get worse before they get better. Here's the cash flow for the different policies. The surge policy, the temporary renewal, things get worse, you're spending money up front, and then, there's small benefits. The policy we just looked at, things get worse, you have to spend more for longer, but then they get dramatically better, and that's why the net present value of all this is so large. I'm not going to go into any detail here, but the worst before better period here is about a decade. We can do that. And in fact, we have been doing it. We also did, and I won't dwell on this, but we also did extensive sensitivity analysis because there's a lot of uncertainties here. And if the discount rate is higher, it's still positive net present value. If the potential for energy efficiency improvement is less than we think it is, then it's still net present value positive. If energy prices fall, it's still net present value positive. In other words, we can be highly confident that even if the model turns out to be over-optimistic, it's still a wise investment for us to do this. And if things get worse, energy gets more expensive, which it did, and energy efficiency potential improvements get bigger, which it has because technology has gotten better, then we make even more money. So this is a no-lose, win-win proposition. So what actually happened? We've issued $1.3 billion in bonds to fund this. $200 million, not 150, in real dollars, so for renewal, all the way out through 2030. We created a program to do what's called continuous commissioning of our buildings. So there's a team of people who go around and make sure that buildings are continuously evaluated for improvement opportunities. And just to give you a real life example, when we started this, we meaning MIT, we sent our maintenance people around, and they would find, for example, in our biology building, that the heating and cooling controls were set so that the building was heating itself and cooling itself at the same time. How did that happen? It made the people in the building happy. When you stop doing that, you save a lot of money very, very quickly. We also changed the structure of the organization. We created a new position, the Director of Sustainability. She's a wonderful person and very skilled at this. Her name is Julie Newman. She now runs what we call the MIT Office of Sustainability, which is charged with improving the sustainability of the whole campus, the education, the student experience, and working with facilities to do this work. And she reports directly to what we call our Executive Vice President, so basically the CFO and Chief Operating Officer of the campus. So it's a very senior position. And we have a climate plan that has been revised a couple times with a pledge to achieve net zero emissions by 2050. There's no way to do that without this work happening. So what else has been going on? Since we did this paper, almost all of this has been implemented and some more. There's still a backlog of deferred maintenance. We're not at 2030 yet, but it's smaller than it was. There's many parts of the campus that are now doing much better. Still a lot more work to do. And we're gradually escaping the trap. So let me wrap it up and we'll see what kind of final questions you've got. So I started out
asking the question of how do you save a leaky ship? So this one is in deep, deep trouble, right? They're bailing as fast as they can. How do you say bailing in Spanish? Shoveling the water out. Okay. So, okay. Achicar. So how do you save a leaky ship? So the first thing is you've got to bail out the bilge. If you don't bail the water out, you're going to sink. So you have to reassign people from working harder, sailing the vessel, to bailing. That's the worst before better. You've got to do that. But bailing, so what that means is you have to prepare for the worst before better behavior. If you're not ready to deal with that, you're going to cancel the program and then you're going to sink. But bailing is exhausting. You can't do it for very long before everybody gets too tired. So you have to bail faster than the water is leaking in. If you bail and remove the water from the bilge, but it's flowing in through the leaks faster, you're still going to sink, just not quite as fast. And it's exhausting to do this, so you have to plug the leaks. You have to plug the leaks faster than new ones arise, faster than new leaks spring, and then rebuild the hull faster than it ages and decays. In other words, you can't just bail, that's working harder. You've got to improve capabilities. This is what organizations have trouble with. So you've got to improve capabilities so that the investment in capabilities rises and the erosion falls so that investment exceeds erosion. Then you have to learn how to do all of this faster than you exhaust the crew and burn out your workers. And that's not easy, right? So we can't make Santiago work more than 80 hours a week because he'll burn out and then he'll quit. He'll go to some other university, right? So we've got to make sure that we learn how to do this. And so building capabilities is itself a capability we have to develop. And then the last thing I think is critically here is when it starts to work. So now you've bailed out the water, you've plugged the leaks, things are starting to get better. Reinvest the labor that's been freed up by that work in further improvement before sailing on. Reinvest those savings in further improvement. If you do those things, then you can turn it around, save your ship, and achieve high performance. So let me stop there and see what kinds of questions and challenges and comments you have. I think we have a couple minutes. Yeah, go ahead. Yeah. Can we get you the microphone?
So, first of all, thank you so much for this really good contribution. So, it's been a really good conference. And I have a specific question. So, do you make a specific partnership with some facility management companies or real estate management companies such as DLS, Virtualis, or something like that?
We haven't. We're not a consulting organization. So the way it works is we publish our research so anybody can use it. We have people from those and similar companies who come through our programs and learn these tools. And actually, my colleague Nelson Repenning and his colleagues, they've created a consulting company that has done many, many, many successful projects. And if you're interested, I'm not here to sell or promote consulting services, obviously. But if you're interested, I can get you the.
I just did the question because, so in this facility management policies program, so it's very important to try to, to have the guarantee in order to do the really good job, the really good performance, the facility management work. So that's,
So, absolutely right. And one of the things I try to do personally, most of my time is spent on climate change, but this is relevant to climate change because energy use and emissions go down. What I try to do is I can use my role to present this work to senior management. So I showed you the hospital at the very beginning. I presented all of what you've just seen in a meeting of their board of directors with the CEO, the members of the board, and the senior leaders, the heads of nursing and critical care and the chief medical officer and all these people. And we did a half-a-day workshop where it wasn't just a presentation. I had them identifying what are the capabilities that are important and what happens if those capabilities are inadequate. And you might be surprised. One of the financial people said, if we don't solve this problem that we've got with poor reliability, et cetera, we won't be able to get insurance anymore. And then we'll have to shut down. And the head of nursing said, if we don't solve these problems with the equipment failing and so forth, patients are going to die. This had a big impact. And I can't share what's happening now, it's confidential, but so my role is to try to help communicate this in a way that really leads to action to everybody from the board and the CEO down to the people who have to make it happen on the ground.
Thanks so
I
much.
hope that helps. How about in the back? Other questions? People in the back? Yeah, way back. Go ahead.
Well, I got a quick question because you have shown us like those really good examples where you take something and you like change it. I mean, you change the whole way from how it works. But I really want to know because we are all gonna go to companies and we're gonna start something, which is gonna start the most of the cases something which is not working. So how do you deal with the frustration that something doesn't work? And how do you say it's gonna get better, but you don't see it? So how do you deal with it?
Wow.
How do you deal with your boss's frustration?
So that's a big question. Thank you for asking it. And, a short cop-out answer is make sure you take classes beyond engineering. Take classes in organizational behavior, psychology. Take classes in all the human sides that you need to build your personal capabilities to identify what's really important for the organization and for yourself, and keep your work-life balance so that you don't get frustrated. This is really important. What does your sign say out in the hallway at Engineering for Life?
Ingeniería para la vida. Engineering for life.
Exactly. This is a much bigger concept of how to be an effective engineer or technical person than just learn the math, learn the engineering, learn the science. That's critical. You can't live without it, but it's not enough. You also have to develop your capabilities to be effective as a person in an organization with other people. Now, the frustration part, I'll share something very personal from my own life. Those of you who were with me in the morning, you know that I spend most of my effort trying to get climate policy that can help create a safer world for everybody. Things are going in the wrong direction in many ways. And the climate is getting worse faster than we thought it would. This can be very, very depressing. So I don't share this with every audience, so I'm gonna be totally open with you. There are days when, I come back from trying to do this and I couldn't make any headway, and I read what's happening in the world, the floods, the droughts, the fires, the migration, the deaths from climate change, and there are times when it just overwhelms me and I become terribly, terribly sad and depressed. And there are literally times, there are some days when I weep, I cry. So what do I have to do? The first thing is sit with that feeling for a while. You can't bury it. You have to live with that feeling for a while. And then you have to think about, okay, great. If I give up, then what happens? If I work harder, I don't know that it will succeed, but maybe it'll get better. And then the next morning, I try to get up and work more effectively, not just harder, but more effectively, working smarter to try to make change occur. And I'm very hopeful. So there are dark days, absolutely. When I say I weep, I mean that for real. It's not easy. And so I've worked to build a network of people that I can reach out to where I'm feeling discouraged and depressed. And, you know, maybe they had a better day and they can help me feel better. And I do the same for them when they need help. That's what you've got to do. And that's how we're gonna get where we need to go. So everybody faces these frustrations. Everybody gets discouraged. That's okay. Just don't give up. Maybe on that note, that would be a great point to bring this session to a formal close.
Yes.
And if people want to stay and ask individual questions, I'd be happy to stay until Santiago drives me away.
I think the last words were really inspiring, not only all what we did today for this audience, but also the things in the moment. And most importantly is all the resources that the MIT has created. It's really appreciated. And I really invite everybody to use them. I mean, they have the fish banks for sustainability. They have the En-ROADS. They have a lot of resources. We use them a lot here, Professor John, and we really appreciate that. And we really appreciate your time coming here. This is a luxury. This is an honor. And well, thanks a lot to you and the ones that want to stay here and be longer discussing. Thanks a lot. Otherwise, we let you finish the presentation with that.
Okay.
Thank you.
Well, thank you all. Thank you. Okay. So
I guess many people want to ask questions.
that's okay.
Someone wants to ask something?
I mean, I think at this point, if people want to and need to leave, you should feel free to go. You know, it doesn't do any good to keep talking when everybody's brain is full. So don't be shy about that. Okay. If there are questions, go ahead.
So during the talk, you talked about big companies who have mountains of cash. But from your experience, is this model worth it for small companies? Because taking the Colombian team, we have a lot of what we call micro companies that don't have a big cash flow. So is it going to be worth it for one of these companies invest into this thing to prevent into the maintenance? Yeah. So
That's a great question. And in some ways, it might actually be easier for a small or medium enterprise. You don't have as much cash, for sure, but you're also not as bureaucratic. You're not as bound by tradition. We've always done it this way. We're always going to do it this way. People are likely to know each other better in a smaller organization. So it's challenging financially, but that's why you want to build the ecosystem, build the network of other people and other small enterprises that can help you. I don't have time to do examples, but there are examples of small organizations that have been successful in building capabilities and staying out or escaping from capabilities. So, you know, you start wherever you are. You don't have a choice about that. And then you need to adapt the tools to your particular situation. So, yeah, no, right here first.
I don't know if it is a question or a comment, but it has to be related with the community.